Good afternoon, everyone. Dylan. Afternoon, Dylan.
Good afternoon, Mr. To.
Hey.
Good afternoon, sir.
Hey, good afternoon. Three more minutes. I already unlocked the Instead. Can you please sign now?
So the Insta is still locked, sir.
Still locked. No. Okay, let me check.
Yeah, sir.
Still locked. Today is 23 to 4. Okay. Unlock. Okay, already unlocked.
Doesn't care which one.
So now it's 3 o'clock. I believe all of you already received the Smart Science password that I sent before. So for those, in case anyone didn't receive, and it might be because of your name is not in my list. So if you didn't receive, any one of you didn't receive, so please send me email and let me know. Then I will generate the password for you. Okay, this is about the Smart Science. So the website to access the Smart Science and the further details regarding to the online experiments, Dr. Tan will update you. Okay, Dr. Tan will announce about the website. Okay. So let me start recording. Already started. Okay, now can you see the slide?
Yes, sir.
Yes, sir.
So before I move on to the chapter 2, I would like to answer the questions raised by Eve. Eve. So she asked me why in deriving the formula to find the angle between two lines, we need to tangent at these steps. So actually the reason is quite simple. After the class last Mondays, then immediately I can see the points. So actually it is because that if you take the tangent here, then in the second line, when you move from the second line to the third line, it will becomes very easy because tangent theta 1 can be substituted by the M1 and the tangent theta 2 can be substituted by M2 because we know that the tangent theta 1 equal to M1. This is the ideals of the gradients that we studied before. But if instead of taking the tangent, now you take the sine or the cos at both sides, then when you move to the second line, you can't substitute the second line to the third line, because M1 is not equal to sine theta 1, M2 is not equal to sine or cos theta 1. So you can't simplify it. Okay, so this is the reasons why we use the tangent at these first steps. Okay. Now, chapter 2. Now, this chapter 2, vector geometry, the chapter 1 is the coordinate geometry. The main difference, as I briefly introduced to you in Mondays, is that vector geometry, we don't rely on the coordinate geometry. Because vector can be independent of this coordinate geometry. Let's say now what is vectors? I assume that you know a bit about this vector. So normally vectors we will use arrows to represent it. So these vectors would be the same. You can move it. Let's say you can put it here, or you can move it to somewhere else. Let's say you put it, one is put it here, another one you put it here. So since you translate, when you move these arrows to this side, provided as long as you keep the direction same and the length of the arrow same, these two vectors we will consider as the same. Now I assume you have some basics. Anyways, later I will explain again about this point. So now when you draw this vector, actually you do not need to specify what is the x-axis and then what is the y-axis. Let's say if you draw an x-axis and y-axis at here, then this is a vector, correct? But if I draw this coordinate, this axis at here, I make it longer. Okay, this vector, you see the directions won't change, the magnitude also won't change. You understand? So that means we can talk about a vector, whether we put it here or we put it somewhere else here. Then you will see that these two vectors actually they are the same, although the locations in the coordinate system that we built is different, because the key elements for a vector is the length and the directions or the angle that it points. So it won't change when you move the vector. It won't change when you build. Let's say now if you change the coordinate system, instead of just now we put it there, right? So now if you move it here, this is the x-axis. And the y-axis, you move it, this y-axis, now you move it to here. So you will see that now one of it is at the right-hand side, another one is at the left-hand side. But both of these vectors, again, we can treat the same. Because their directions, they point to the same directions, they have the same length. It doesn't change for these two components. So that means the conclusion is that this x-axis and y-axis actually is not important. We can just remove it. Just simply draw a vector like this, then we'll know we get the informations that it's necessary that we want in solving the solution. Okay, so this is the basic idea for vector geometry, which is a difference from the coordinate geometry. Coordinate geometry, we need to show where is the what is the coordinate. When we say the coordinate, when we state the coordinate, means that we need to know where is the origin. That means where is the x-axis, where is the y-axis. Okay, but vector geometry no need. So later when we go through the examples and the questions, you will see that we will only have the symbols for the vector, but we won't in general we won't draw the x and the y coordinate unless for the teaching purpose I draw it for you. Okay, but when you solve the questions, you no need to draw it. Okay, this is the properties for the vector geometry. This is one point before I start the vector geometry. The second important point is that why we need to study this vector geometry. The things that we investigate is the same, geometry, geometrical object. But the tools is different. The coordinate geometry, we use the numbers, a pairs of number and the algebraic expressions to study the properties of the line and the point and the shape of the geometrical object. But now this one, we instead of using a number to a pair of number, now we use vector. Okay, we use vector. So that means that the tools would be different. As I mentioned in the Mondays, why we need to study different tools? Because when you go to the higher levels, okay, your final year project in UG, your master thesis and your PhD thesis, you can't rely only for one tools. You have to know many tools. That is why you study MATLAB. You study MATLAB. Sometimes some people, especially for the physics students, they study Mathematica. Why? Because they need to use it to solve problem. But the theory, they use the Mathematica, let's say the MATLAB to, let's say, doing calculations about the metrics, about the differentiations. But maybe you ask, differentiation I already learned, then what for I learned the MATLAB? Because they are considered as a different tools. Okay, different tools in different contexts, they can help you in the different way. So you cannot just rely on only one method. Okay, only one tools. That is why we have this coordinate geometry, vector geometry, and later complex number, and then followed by this matrix. Yes, because all these topics actually is very closely related to the geometry. Okay, now the learning outcome. These are the learning outcome. And again, I think I will come back to this slide after we study all these, all the concepts that mentioned in this slide. Example, what is the vectors, how to represent vectors, how to add the subtract and the subtract vector, how to check whether 3 points are collinear. You still remember collinear? Collinear, we study in the first chapter, how to check whether 3 points are collinear. You calculate the gradient. You check the gradient between two pairs of the coordinate givens. And if you find that they are the same, then they are collinear. But now we don't have the coordinates, okay, but we have vector. Then how to check the 3 points givens are collinear? Can see, same thing, same concept about collinear, but we use different tools to check whether they are collinear or not. Okay, so we will come back to this slide after we finish at the end of these topics. Okay, so this one I already explained. In this chapter, we should explore the basic concept of vector and study the general properties of vector and its application in simple geometry. But now, what is the vector? Actually, vector you already learned. Vector and scalar is a pair of concepts. Normally, we will mention it together at the same time. Scalar is comparatively, it is very simple. It is any quantity, of course, it's a physical quantity which is involve only magnitude, only the magnitude. We call it a scalar. But if there is another set of the quantity in physics and mathematics where only knowing about the magnitude is not enough. We need to know also about the directions of the quantity. So if you need to know about these two info or the components, then we are saying that we are dealing with these vectorial quantities. One is a scalar, one is a vector. But these ways of the explanations and defining the scalar and the vector actually is not complete. But I think you will be very familiar with this, because this kind of the statements and the definitions you read it since your high school. Okay, but if you study the mechanics, I think in the class of the Dr. Tan, I think you should know that these vectors, what is the more important things, more important differences between the scalar and the vector is that this scalar and the vectors, they obeys the different rules of the calculations. Okay, the rules of calculate the scalar and the rules of calculate the vector, they are different. Of course, they have the different physical effect between the scalar quantity and the vector quantity. But the more important thing is that you need to appreciate that the difference, important difference is that they follow different rules of calculations. For example, in scalar, you study this since kindergarten, 2 plus 1 equal to 3. But in vector, you know that a vector with the 2 unit plus a vector with 1 unit, not necessarily you get another vectors with the 3 units. So that means that the ways of manipulating the vectors, whether you add it, how to add it, how to subtract it, how to multiply it, they are different. In vector, there is no division concept. And in vectors, there are 3 types of the multiplications. In scalar, only 1 type, but in vector, there are 3 types of the multiplications. So you can see that actually they are very, very different. But for these modules, part 2, I wouldn't go deep into this, because this one should be already explained in the mechanics, by Dr. Tan. So I will put aside this part, but now I will focus on how to use the vectors to study the simple geometric property. Okay, so example for scalar is time, distance, and the speed, and for vectors is the displacement, velocity, and the accelerations. Okay, so maybe I need to add, even though you let's say you forget everything which is explained by Dr. Tan, doesn't matter, if it won't affect the things in this chapter. Okay, so because I will start again from the very basic concept for this vector, although the depth between my one and his one might be different because it is considered as 2 different modules. So the things that we emphasize is a bit different. Okay, so now how to represent the vectors by directed line segments. Okay, we have different ways of represents the vector. Okay, one of the ways is we call it as a graphical method. Okay, in again in where in the mechanics. In the mechanics, the more efficient and convenient ways is not represents the vectors by using the graphical method. It is using the analytical method, where you use the symbols of the I, J, and the K, the concept of the unit vector. But now we use the graphical method. How to represent the vector by graphical method? Let's say now from a point A to the point B, you draw a line. Okay, this A and the B is denotes the this is the tails, this is the head of these vectors. And then if you draw this line, the length of the line will represent the magnitude of the vector. And vector, remember, vector can be displacement, can be velocity, can be accelerations, can be force, can be momentum. Okay, the example for scalar can be time, distance, speed, energy, what else? Energy. Okay, so many in physics. What else? I forgot. Okay, so but anyways, the vectors, the vectors is actually the example will be more, and actually it will play more important roles in physics and mathematics. So now, since vector got magnitude and the directions, so this magnitude is given by this line. You can draw it based on the exact scales if you want. Let's say 1 cm equal to how many Newton, 1 cm equal to how many meter, okay? And the directions of the vector is represented by the angle, okay? We measure the angle with respect to the horizontal. This horizontal, you can treat it as the positive directions of the x coordinate. You can say that, oh, this is with respect to the positive x axis. Okay, so if you measure the angle between this line and the vector, now you put the tails of this vector on the horizontal line, then these two lines will make an angle, correct? This angle, if you measure it following the anti-clockwise directions, then it is called as the positive angle. If you measure in the negative directions, then it will becomes the sorry, just like I said, anti-clockwise is positive and then clockwise is negative. Let's say, for example, you can say, let's say if this angle is 30 degrees, so you can say that this vector is pointing in the angle of 30 degrees with respect to the x-axis. But also you can say that it is pointing in the negative 330, correct? Because the positive 30 is equivalent to negative 330 with respect to the positive x directions. So either you say that it is 30 degree or negative 330 degree doesn't matter, because it will in fact points to the same directions that shown by this this diagram, this arrow. Okay. So if you don't use this graphical method and you use symbols, then we denote this this vector as a AB. A from A to B. On top there's an arrow. Can see this arrow is point from A to B. Means that the direction is from A to B. Okay. So if you swap, it becomes B to A, then the direction will be reversed. Okay. So the sequence of the sequence of the symbols will be very important in this chapter. AB and the BA, they are not the same, but they are opposite with respect to one another. Okay, so vector also denoted by single symbols like this, especially in the mechanics. We normally use single symbols to represent the vector. But now in this chapter, it is more general, more common to denote the vector by two symbols together with arrows. Okay, but the magnitude of the vector is given by the two symbols, but without the arrows. Without the arrow means refer to the magnitude of this vector AB. Or if you don't want to remove these arrows, then you can add two vertical lines, which is refer to the magnitude or the absolute value also can. So if this is a C single letter, then you use the you can also add two vertical bar to represent the magnitude of the vector C. Magnitude means this length of the vector. Or without the arrow, on top only single letter C. Okay. So again, you need to, for the directions, you need to write down or specify what is the angle between the vectors and between the vectors and the x-axis. So two vectors are equal vectors if and only if, this one still remember these symbols, if and only if these two vectors have the same directions and the magnitude. This one means magnitude. The vector A and the vector B, now I use a single letter, you see, also small letter, and they are equal. These two vectors are equal if their magnitude are the same and the directions are the same, magnitude are the same. Just like the example I give you just now. Let's say now if you have this vector, you have another vector, you put it, you draw it at the different places, but To check whether these two vectors are the same or not, you have to check two things. One is whether their angle, their direction is the same or not. How do we know the direction is the same? Okay, you use protractor. You use protractor to measure what is the angle of this, and then measure what is the angle of this. If the angle is the same, not enough. You have to check another things, which is the magnitude, the length of this vector. See, these two are the same length or not? Oh, okay, they are the same. Direction same. That means these two vectors, although you draw at the different places, you draw separately, but in concept, we should treat them as the same, as the equal vectors. Okay. Now, example. We have this P, Q, R, and S. These are the now P, Q, R, and S. These are the four vertices, 4 points. Okay, so there are P, Q, R, and S are vertices of a parallelogram. I hope you still remember that I mentioned before. By our conventions, we will denote or labels the vertices of the geometrical object following the sequence should be following the anti-clockwise directions. So if you put this one as a P, then the Q must be this one, followed by R and the S. But if you put the S, this vertex as a P, then this one should be Q, this one should be R, this one should be S. This is our conventions. So for this parallelogram, you look at this diagram, you see, we are not only have this line, we also have the arrowhead. Actually, we have the arrow here. So that means we have actually 4 vectors shown in this diagram: PQ, QR, SR, and the PS. Okay, so PQ and the SR is considered the same vector, equal vector. Why? Because if this is a parallelogram, that means the PQ and the SR, they must point in the same directions and they are equal in length. Therefore, they must be considered as the equal vector, same vector. Similarly, the same thing happens for PS and the QR. They are points, they are pointing in the same directions and they have the same length. So these two vectors are considered the same. Okay, another concept, this is a concept about what is the meanings of equal vectors. And then the next concept is about the negative vector. I hope when you attend my lectures, you can see, of course you need to follow my lectures, but you don't follow, how to say that, you must follow when you attend, when you try to understand what I am explaining. You must also at the same time to be able to see the structures of the lectures. You understand? You must be able to see the structures of the lectures. So you see now actually we define what is a vector, and then after that we have to check, we have to define also what is the meaning of equal vectors, and then what is the meanings of negative vector. Why? Because vector, they are not the same as scalar. Scalar, we already know what is the meanings of the equal number. Equal number means they must be the same magnitude. That's all. We are very clear about the meanings of equal in the scalar. We also know what is the meanings of the negative number in the scalar. But in vector, what is the meaning of negative vector? So can you see that the structures of our learning actually is that we need to start from the beginning. We need to start from the most basic concept before we can apply it to study the geometry. So now actually we are defining what is the equal, basic concept, what is the equal, what is the negative, okay? Later, what is the meanings of additions, what is the meaning of subtractions of vector. I hope you can see all these things will repeat again and again, at least 2 more times in matrix and in complex number. So I hope you can see this is the structures that we are going we'll go through in this semester for this part 2. Okay, so Next concept is the negative vector. You see, what is the meaning of negative vector? A equal to negative B. If and only if this AB, they have the same magnitude and the opposite directions. If it is the same directions and same magnitude, then they are equal. But now they have the equal magnitude but opposite directions, then it is considered as a negative vector. This is a concept of it. But how would it look like in graphical representations? Okay, so I give you one example. Again, we consider parallelogram PQRS. See, follow anti-clockwise PQRS. So based on this diagram, you can see that this PQ is equal to negative RS. Why? You see this arrowhead is pointing from P to Q, but this one is pointing from R to S. So they have the same magnitude in length, but directions difference. Therefore, they are not the same. Okay, they are opposite. They are considered as the opposite vector. Okay. Another example, another pair of the vector which is opposite, considered as a pair of opposite vectors is the PS and the RQ. You see, this is the PS, this is the RQ. Points from P to S. This one is point from R to S. So that's why just now I said, I already mentioned that the sequence of the symbols is very important. P to S and S to P is not the same. So based on the diagram, you should write P to S as shown in these pictures. You cannot put it as a SR. If you want to put it as a SR, you have to add a negative sign. Okay, and this one should be R to Q, not the Q to R. Okay, so they have the same magnitude and opposite direction. So this is the meanings of the negative vector. RS is the negative vector of PQ. RQ is the negative vector of PS. Okay, next concept. What is the meanings of scalar multiplications of a vector? Scalar multiplications of a scalar, you already know, right? 3 times 5 equal to 15. 2 times 6 equal to 12. All of this you already know since standard 1. But what is the meanings of the multiplications of a vector? Now we will only study one types of the multiplications in this part 2. Another 2 types you should have already studied in Dr. Tan's class, which is a scalar products and the scalar product and the cross product. Okay, which is very important in physics. Okay, but now we only talk about this scalar multiplications of a vector. What is the meaning of it? Let's say now A, this is a vector A. You multiply with a scalar K without an arrows, means a scalar. You get another new vector, which is B. Okay, if K, this number K is larger than 0, means that this vector A, when you multiply with K, what is the meaning of it? It means that this vector A is pointing in the same directions, and the magnitude is equal to the magnitude of the K multiplied with the magnitude of the A. You get the magnitude of the B. For example, I give you an example. Let's say now you have a vector A. This is a vector A. Vector A, let's say vector A is how many units? 10 units. 10 Newton, let's say 10 Newton. Pointing in this direction, 45 degrees, let's say. Now, if you multiply with a number which is K equal to 2, that means the effect of multiplying with these 2 is that this vector A is being stretched by 2 times. It will become 20 Newton, but the directions won't change. Okay, the direction won't change. But if the value of K is smaller than 1, let's say K is equal to 0.5, also positive, right? Still positive. So that means now the effect is that instead of stretching the vector, now you are compressing it. You shorten it by half. Okay, so it depends on the magnitude of the K. If it is larger than 1, means that you are stretching it without changing the directions. If it is less than 1 but still positive, then that means you are shorten it. You are make it contract. Okay, so this is the meaning. You cannot just understand the symbols but without seeing the pictures in your mind. What is the effects of doing that? Okay, so but if the K now is less than 0, then the effect is that you reverse the directions of the vector A. It will point in the opposite directions. But the magnitude also, you take the magnitude of the K, you forget about the negative sign, you take the magnitude of K, you times the magnitude of A, you will get the magnitude of B. Now, for example, if you multiply this vector A initially with 10 Newton, the force, now you multiply with K equal to negative 2. Negative 2. I think I use the equation better. K equal to negative 2. Okay. That means, what is the effect of it? It means that you are stretching it for 2 times, becomes 10 Newton, but at the same time, you have to reverse it. It becomes like this. This is a vector B. This is vector A. This is vector B. Okay. But now, if you multiply with the K value, which is less than 0, also less than negative 1. So let's say negative 0.5. So what is the meaning? The meaning also the same. Now, instead of stretching, you shorten it, compress it by half, and then at the same time, turn it, reverse it to the opposite direction. This is a negative 0.5. Okay? The meanings of the scalar multiplications of a vector. Now, I give you an example. The points M and N in this triangle are the midpoint of the side PQ and the PR. This is PQ, this is PR. Let's say M is the midpoint of PQ. You already know what's the meaning of midpoint from the first chapter. And then also you have the N as a midpoint at the side of the PR. Therefore, we know that this QR is 2 times of the MN. I don't want to prove this. Actually, you can prove it by basic properties of this geometry. Now, I assume that we know that this is half. Okay, this is half because these 2 points that we consider is at the midpoint. So it should be 2 times. QR is 2 times of the MN. Okay, now let's say we accept this. We put aside about the proof. Then what I want to emphasize is that when you see this QR equal to 2mn, means that these 2 vectors, they must point in the same directions. Okay, that means this angle and this angle must be the same. Okay, and then in terms of length, this one must be 50% of the length of QR. So if you want to make this mn as a subject, then of course you can bring this, move this 2 to the left hand side, becomes half. Then you get this relationship. Mn equal to half of QR. You can see or not? Actually, you can as you follow your wish. So which one you want to put it as a subject actually is okay, but you must understand it. What is the meaning of it? Like this one is 2 times, but this one is half only. Okay, and another pair of the vectors that we need to discuss is about the RQ. Now, if instead of QR, now if you talk about the RQ, that means that the direction is opposite with the one that's shown in the diagram. Okay, but the MN is the same direction. Correct? So that means you have to add a negative sign. Negative sign means opposite directions. So RQ is the opposite with the MN. But QR is the same directions of MN. So negative 2 times. Negative 2 times. Don't forget about the negative. Sequence of the symbols important. And again, if you want to put the MN as a subject, you get negative half RQ. Okay. This is scalar, the meanings of the scalar multiplications. Next concept is a unit vector. In scalar, you study scalar since standard 1. You already know what is the meaning of unit scalar. Unit scalar means 1. You already know how to count 1, 2, 3, 4, 5, maybe at 3 years old or 4 years old. So that is the unit scalar. Because a unit scalar. But in vector, maybe you ask, hey, what is the meanings? Is there any corresponding concept about this unit scalar? Yes, we call it unit vectors. Okay, but what is the meanings of unit vector? Unit vector is any vectors. U can be represents any vector. Momentum, force. What else? Momentum, force, velocity, anything. If the magnitude is equal to 1, we call it as a unit vector. Directions, it can be points to any directions. So provided their magnitude is equal to 1, then we can call it as a unit vector. But the definition, I think, is quite simple. But I think the more important thing is that you need to appreciate about this point. Any given vector A, you can rescale it. Correct? Just like this example, we can simply, if you want, you can multiply with numbers to change the length. You want to stretch it, you multiply with k with positive value. You want to compress it, then you can multiply with a number with less than 1. Correct? This is the meaning of rescaling. So these vectors actually we can rescale. Okay, depends on your purpose or your objective in solving the problem. That means depends on the context. So you can rescale the A to make the magnitude of it becomes 1. If you make it becomes 1, then this vector A will becomes unit vector A. You see the symbols difference. At the top, this is the arrow. This one is the shape like a hat, like a cap. Okay, so these symbols means unit vector. Okay, this symbol means unit vector. So mathematically, in terms of operations, that means you can always rescale it to becomes 1. But mathematically, we can express it in through these expressions. The unit vector A is equal to this vector divided by the length of it. Can you understand? Can you understand? Let's say now you have a vector. This is a vector, let's say 10 unit. Again, 10 Newton. 10 Newton. If I use the scales for 1 cm to represent 10 Newton. Okay, so I can rescale it to becomes 1 cm. If I rescale become 1 cm, then this one no longer vector A, because it's a unit vector A. This is operations that we can perform by making it shorter. But mathematically, it means that now this vector, which is pointing at, let's say 45. If you divide by the magnitude of it, that means 10 divided by 10. You use 10 divided by 10. 10 divided by 10. You always get 1. Correct? So if you have 12 units, then you divide by 12, you get 1. If you have 15 units, you divide by 15, you get 1. You always divide by the magnitude of the vector that you want to make it as the unit vector. Then you can always get the unit vector. Okay, this is the idea. Now I give you an example. Figure below shows a grid with a parallel line. This is all parallel line. PQ, MN, and AB. Now AB is given as the U. We denote this vector AB as the U. PQ as the A. MN as the B. Okay, M to N, opposite directions. Now the question asks you to express the A and the B in terms of U. A and the B in terms of U. This is in terms of A, this is in terms of B, this is in terms of U. So now the question asks you to express the A in terms of U. Then how to solve? Okay, now you look at this diagram. We have, if this is AB, this one is the A, then we know that these two should be in the same directions. But PQ is 2 times longer than AB, all right? So I can write down the first line, PQ equal to 2AB. Positive, positive means that direction same, magnitude is 2 times. Therefore, we can know that this A is equal to 2U. Very simple. And then how about MN? MN, in terms of magnitude, they are 3 times compared to AB, but opposite directions. So we can write down the relationship between the MN and the AB as this. MN equal to -3 AB. MN equal to -3. Don't forget about the negative. This one this one is positive, this one is negative. So it depends on the directions. And then we can know that this B, because MN is equal to B, B should be equal to -3U, because AB equal to U. This is the meanings of express the A in terms of U and the B in terms of U. I hope you can understand the statements, the questions. Express the meaning of in terms of. If you don't understand this, then in the test, in the exam, how to solve? You can't solve, correct? You do not know how to put your answer in what form. Okay, in terms of, this is the meaning. That means right hand side only got the U and the certain numbers. Now B said if this U is a unit vector, we define this as a unit vector. Find the magnitude of the A and the B. What is the magnitude of A? What is the magnitude of B? Okay, you look at this diagram, then actually it is obvious, because this A, magnitude of A, you see this is magnitude of A, is equal to the 2 times of the magnitude of U, correct? Actually, these two vectors are the pointing along the diagonals of all these boxes, diagonal line. So it is easy to compare that this A actually is 2 times of this U. So magnitude of A is equal to the magnitude of 2U. Please pay attention on how to write this. If you write A equal to 2U, this is a difference meaning. This one is a vector, you are talking about a vector. This one you are talking about the magnitude. So don't overlook the vertical bar. Okay? So it should be like this. Therefore, what is the magnitude of the A? If the magnitude of U is 1 unit, then the magnitude of A should be 2 units. Because 2 times 1 equal to 2 units. Similarly, for this B, you see the magnitude of B is equal to the, based on this equation, I think I put it here. B is the -3U. So the magnitude of B should be modulus of this -3 times this magnitude of the U. That means that this modulus means that you just put aside this negative sign. Just consider the positive sign. Then you get the answer should be 3 units, because the unit of U is 1 unit. The length, the length of the size of the U is 1 unit. Therefore, you get 3 units. Correct? So this is about the unit vector. So do you have any questions so far?
Very clear, sir. Question.
Hello.
No question.
No question, sir.
No question. Okay. Because if there's no questions, next concept is about these additions of vector. This one I think is a bit long to explain it. So, and then we have only another 4 minutes. So I think I will stop here. So do you have any questions? If you have questions, then we can discuss. Another four minutes. So please, this tomorrow, today is Thursday, right? Tomorrow night, again, we have the second sessions for the Q&A. So I hope that you can, if you have any questions about the lectures, about the tutorial, please attend. And also tonight, after this, I will upload the video, also upload the notes. I already upload, right? I hope you already get it, because last night I tried to upload, but the Moodle is not working. So I uploaded it this morning. And the tutorial solutions for the tutorial 1, I promise to release today. So later I will release together with this video. So that means tonight or after, I think tonight when you go and check, you should be able to get it. Do you have any questions? 2 more minutes.
Sir, I have a question regarding the maths quiz.
Yes, please.
Will it be held on next week, Thursday?
It's Thursday. Yes, next week Thursday.
Oh, okay. Will it is it until where we learn, or will it be only chapter 1? I mean, yeah, chapter 1.
Okay, the quiz would be until the next Monday's lesson.
Oh, all right. Thank you, sir.
I will remind you again next Monday. But again, because as I said before, the quiz question should be, the reasons we give quiz actually is to help the students to follow our teaching pace, So I will only set the simple questions. You must make sure you understand the lecture notes. You just focus on the lecture notes, and the example you must make sure you can solve. That's all. Enough. Tutorial, no need. Tutorial actually is for preparations of these midterms. You need to solve before the midterm. But for quiz, only focus on the lecture notes.
So, sir, I mean, like, if we complete our tutorial, will we still be considered as ready for the quiz if we complete our tutorial?
Consider as what? Sorry.
Will we be considered as will we be ready for the quiz if we complete the tutorial?
Of course, because because if you can solve tutorial questions, that means quiz should be very, very easy for you.
Right. Thank you, sir.
Any other questions?
Sir, the quiz 1 is just for chapter 1, right?
No. It's for chapter 1 and 2 until the next week's lecture.
Okay.
Next Monday's lectures. Any other questions?
Sir?
Sorry, I already unlocked again the instead you may sign in. Yes?
Sir, for the quiz, does Dr. Maxine stuff, like, are they like involved in this quiz, or are they like separated?
Okay, actually in the quiz, we will conduct my part 1, part 2, and Dr. Maxine one part 2, part 1 and my one part 2. We will conduct it together at the same times, but we will prepare 2 documents. We will set up two links in the Moodles. So you will need to download 2 papers and then answer it, and then after that you must submit it in through the 2 links. But we will do everything at the same time slot. You understand?
Yes, sir. Thank you.
Anyway, don't worry, because you try to attend earlier next Thursday before the quiz. We will brief you. Don't worry.
Sure. So during the quiz, we have to answer your part of the question separately and Prof. Maxim's part separately, and then upload it separately as well.
Yes, you're right.
And
Everything you have to put it separately. Answer script also separately. Upload also separately through a different link.
And the time duration for that would be?
Time duration is the same. That means within the same time duration, you have to solve 2 parts.
Okay, thank you.
What else? If you have any other questions, you can always send me message through the Teams, or you can attend the Q&A sections. I think now I better dismiss you because you have